A particle is fired at a screen with two holes in it. Nobody's watching. It goes through both holes at the same time, spreads out like a wave, interferes with itself, and creates a rippling striped pattern on the wall behind it. Now the exact same particle is fired again. This time, you watch to see which hole it goes through. The wave pattern disappears. The particle goes through exactly one hole and hits the wall like a bullet. Same particle, same setup, same two holes. Different result because someone was watching, and scientists have now confirmed this in the most precise experiment ever performed at MIT in 2025 with individual atoms as the slits. This is not a theory. This is not philosophy. This happens every single time. I am your host. You are watching Photon Path, and today we're going somewhere that will permanently change how you think about what is real. Let's start with the basics, because you need to feel how weird this is before we go further. It is 1801. British physicist Thomas Young shines light at a screen with two narrow slits. On the wall behind it, he doesn't see two bright strips of light the way you'd expect. The way a garden hose spraying through two gaps would make two wet patches. Instead, he sees an interference pattern, alternating stripes of light and dark. Many bands, not two. This is because light behaves like a wave. When it passes through both slits, the two waves spread out and overlap. Crests meeting crests to make brightness, crests meeting troughs to cancel out and make darkness. Like ripples from two pebbles dropped into a pond colliding in the middle. Fine, light is a wave. Makes sense so far. But then quantum mechanics arrived, and scientists realized that light also comes in individual particles called photons, packets of energy, discrete little bundles. So they tried the experiment again, this time firing photons one at a time. One photon, one shot, hit the wall, no wave to interfere. Right, you'd expect two bright patches to slowly build up from all those dots. Particle goes left slit, dot on the left. Particle goes right slit, dot on the right. Simple, but that is not what happens. Even when each individual photon acts like a particle, hitting the far wall in one specific spot. After enough photons arrive, the same interference pattern emerges. The wave nature of a single photon interferes with itself to create the pattern. The photon alone, one at a time, somehow goes through both slits, simultaneously interferes with itself, and conspires with all the other photons to build an invisible wave pattern. One particle, both slits, at the same time. Okay, weird. But it gets so much worse. Scientists decided, fine, we'll just watch. We'll set up detectors at the slits and catch the photon in the act. We'll finally see which slit it actually goes through. They turned on the detectors. The interference pattern vanished. Completely gone. Just two blobs. Exactly what you'd expect from a particle. They turned the detectors off. The interference pattern came back. In the MIT 2025 experiment, researchers discovered a clear relationship. The more precisely they determined a photon's path, confirming its particle-like behavior, the more the wave-like interference pattern faded. Getting information about the photon's route automatically erased its wave-like properties. YouTube-ond, this is where your intuition breaks down completely. Because the detector doesn't touch the photon, it doesn't hit it or push it off course. In the 2025 MIT experiment, they used individual atoms cooled to near absolute zero as the slits, detecting the photon's path by measuring subtle quantum changes in the atom's properties after photon scattering. The gentlest measurement imaginable. MIT knew it didn't matter. The act of observation itself influences the behavior of particles, fundamentally changing their outcomes prior to observation. A particle exists in multiple states simultaneously. The photon seems to know it is being watched. Now here is the question that should keep you up at night. What counts as watching? Does it have to be a human, a camera, a detector that nobody ever reads? What if the information exists somewhere, but nobody looks at it? Physicists asked exactly this, and their answer became the most disturbing experiment in the history of science. In 1982, physicists Marlin Scully and Kaidar E. H. Hell proposed something extraordinary. What if, after marking which slit the photon went through, you erased that information? The quantum eraser experiment establishes that when action is taken to determine which of two slits a photon has passed through, the photon cannot interfere with itself. But a photon that has been marked to reveal which slit it passed through can later be unmarked. A photon that has been unmarked will interfere with itself once again, restoring the wave interference pattern. Think about what that means. You watched the photon. The interference pattern disappeared because you had path information. Then you destroyed that information, and the wave pattern came back. The photon's behavior in the past was altered by what you did with information in the present. But the real experiment, the one that truly breaks people, is the delayed choice version. In this experiment, the photons pass through the slits first. Then, well after the photons have struck the detection screen, the experimenter decides whether to read or discard the which path information. If the experimenter reads the information, there is never an interference pattern. If the experimenter throws away the information, an interference pattern emerges. The photon hit the screen before anyone decided what to do with the path information. The outcome on the screen, wave pattern or particle, depended on a decision made after the photon had already landed. Read that again. The future decision changed what happened in the past. Or at least, that is what it looks like. Now, here is where I have to be straight with you, because this is where the internet gets quantum mechanics badly, badly wrong. The delayed choice quantum eraser does not mean you can send signals to the past. It does not mean consciousness creates reality, and it does not prove time travel. A common misunderstanding about this experiment is that it may be used to instantaneously communicate information between two detectors. Simple causation precludes this. The coincidence detector can only function by comparing data from both sensors, making it impossible to use this setup for instant communication. Space.com. So what is actually going on? The honest answer is physicists disagree. And that disagreement is one of the most interesting open questions in all of science. Here is the most widely accepted framework. The Copenhagen interpretation, it says a particle doesn't have a definite state until it is measured. Before measurement, it exists as a wave of probabilities, a quantum superposition of all possible states simultaneously. Measurement collapses that wave into one definite reality. Under this view, asking which slit did the photon really go through before you measured it is a meaningless question. It didn't go through either slit in a definite way. The question itself doesn't apply. Then there is the many worlds interpretation, which says the particle does go through both slits, but in different branches of reality that split apart and can never interact. You are in one branch. The other photon is in another universe you'll never see. And then there are interpretations that argue something even stranger, that the mathematics of quantum mechanics hints at a universe where information, not matter, is the most fundamental thing. MIT's 2025 experiment was conducted in the International Year of Quantum Science and Technology, marking 100 years of quantum mechanics, and it confirmed that wave-particle duality holds even at the most fundamental quantum scales, with atomic-level precision, YouTube 100 years. And we still don't agree on what it means. Let me leave you with the thought that haunts physicists the most. Wheeler pointed out that if one imagines an experimental setup of interstellar proportions, a last-minute decision made on Earth on how to observe a photon could alter a physical configuration established millions or even billions of years earlier. Physics world think about what that means in practice. Light from a quasar 10 billion light-years away is traveling toward Earth. It split around a gravitational lens billions of years ago, traveling two different paths around a galaxy cluster. Those two beams of ancient light arrive at Earth tonight. You set up a detector. You choose right now tonight to measure which path that light took, or you choose to let them interfere. Wheeler argued that it doesn't make sense to talk about photons in flight. We only have measurements and observations, the final results of our experiments. The order of events and what happened during the experiment itself don't matter. Arxiva decision you make tonight in your lab in 2025 determines whether a photon committed to being a particle or a wave 10 billion years ago, before the Earth even existed, not retroactively changes our knowledge of. According to the math of quantum mechanics, the photon had no definite nature until you chose to measure it. The universe, at its most fundamental level, may not be made of definite stuff. It may be made of possibilities, collapsing into reality, only when forced to by the act of observation. And no one, not Einstein, not Bohr, not the physicists running these experiments today, can tell you with certainty what is doing the observing or why that act makes anything real at all. Here is what we know for certain. Fire a photon at 2 slits. Don't watch, you get a wave. Watch, you get a particle erase the information after the fact. The wave comes back. MIT confirmed it in 2025 with the most precise version of this experiment ever run. Einstein was wrong and Bohr was right. Here is what we don't know. Why? What observation fundamentally is. Whether the universe is made of matter or information or something else entirely that we don't have words for yet. Quantum mechanics is the most successful scientific theory ever created. It underlies every microchip, every MRI scanner. It works with terrifying precision. And not a single person fully understands why it works. That is the honest state of physics in 2025. Not a failure, a frontier. The most exciting frontier in human knowledge. If this made you feel something, like the floor just moved slightly, hit like. It takes 1 second and it helps Photon Path reach the people who need to feel this way too. Next week, dark matter. 27% of the universe is made of something we cannot see, cannot touch, and cannot directly detect. And it may be the force that built every galaxy you've ever looked at. Subscribe, and I'll see you then. Follow the light.